Good morning, everyone. I'm sorry if this looks a bit strange today because I'm actually using two devices to join today as I had some technical issues. But let me introduce myself. My name is Belén Gallego, and I am part of the REMAR by ATA Insights team, which is organizing this webinar that you have in front of you today, this online session on how the EU AI Act is quite a mouthful, is quietly reshaping electricity grids and investment decisions. I mean, we all know that AI is changing things, is transforming how full industries, quite honestly, are going to operate going forwards. And it has a lot of benefits, I think, for everyone, for the users, for the companies that work in those industries. But it's also true that we must have some common rules in order to make sure there are guardrails on how AI is deployed, what data is available, how data is used. I think we all know that. Hence, what we're talking about today, which is precisely the EU Artificial Intelligence Act and how this is changing how grids operate and how investment decisions are taken. I'd like to welcome you all and ask you please to use the chat to introduce yourselves and where you're joining from. I am joining from Madrid, Spain today. And with us, I'd like you also to get to know a bit our experts today. They're all from the EU Joint Research Center at the European Commission. So I'd like to ask first, Davide, could you please introduce yourself shortly?
Hello, everyone. My name is Davide Currò. I'm from the JRC, the JRC C3 unit, and I work in the Smart Grid Interoperability Laboratory.
Thank you very much, Davide. Welcome. And we also have with us Antonio de Paola. Please, Antonio, could you introduce yourself?
Morning, everybody. My name is Antonio de Paola, Unit C3 of the Joint Research Center on Energy Security, Distribution and Markets. And I work on scientific activities of the JRC related to the implementation of AI solutions in the energy system.
Excellent. And last but most certainly not least, Nikoleta, please, could you introduce yourself?
Hello, I'm Nikoleta. Apologize, I'm kind of sick today, so I'll do my best.
You and I will do our best.
Yeah, exactly. So I work in the same unit with the guys, and I will start the presentation, giving you some information about the JRC and also our unit.
Thank you very much, Nikoleta. Thank you for making the effort to be here today. Hopefully, it all go really well. Before we start, I just wanted to ask you guys a few questions. Okay, so this is where you, the audience, become the protagonist. So Maria, gonna have the first questions. It's only to try and see, how much knowledge there is in the audience already. So the first question that we have is, what is your level of familiarity with AI applied to the energy sector? So what is your level of familiarity? How much are you using AI in your job? You only have to click the answer that applies to you. And please, I ask all of you to please participate so that we can get as best answer as possible. The answers are really, really easy. They're I'm only familiar with it at a general level. I use it occasionally in my job, in my work. We have conducted internal tests or pilot projects. And the final question is, answer is, we already have operational use cases in my company. Can we just have a few more of you, please participate? One must apply to you. So, because not a lot of people have participated, there's a lot more of you in here. So I'd just like to see if a few more would go for it. Go on, 5, 4, 3, 2, and 1. Unfortunately, not many people. Go, please show us. Maria, so as you'll be able to see, 52% of people have said, I am only familiar with general level AI such as ChatGPT. Can you share, please, Maria? Some people, 26% have said that they use it occasionally at work, and 22% have conducted internal tests. This is not bad, actually. Other webinars I've seen a lot less, and no one has anything operational. Okay. Can we go to the next question, please, Maria? Oh, I see. So all of them are together. What is your level of familiarity? Oh, okay. How would you define the main AI-related challenge in your organization today? So again, guys, please ask you to answer there. The first is, Actually, we are only doing it at a strategic level because we lack clarity on what we want to achieve with AI. We don't know what we want to achieve, essentially. We lack focus. We have ideas, but not clear prioritization. It's a technical challenge. We know what we want, but we don't have the resources to do it. Is it a cultural challenge? No one wants to do it, or there is resistance at work, or it's not a priority to us. You know, can I just get a few more people vote, please? Because again, you're being really shy, guys. Come on, let's try and figure it out. So is it strategic? Is it focused? Is it technical? Is it cultural? Or it is not a priority? 5, 4, 3, come on, a couple more. 2, 1. Okay, can you show, please, Maria? We got a few more people to vote. So basically, strategic is about 23%. Focus is most of the people, as it happens, 42%. We don't have anyone with cultural issues, which is a surprise to me, actually. This is good news, I think. And 12% of people have said that AI is not currently a priority. And 23% of people know what they want, but they lack resources. Okay, excellent. Let's go to the third question, please. So the third question, I can see the first one again, Maria, for whatever reason. Can you go to the third? Here we go. How familiar are you with the EU AI Act or the European Union Artificial Intelligence Act? Come on, this is very important actually for our speakers. So I would ask that all of you take, it's really easy to be honest. One is deep understanding, another one is a little bit, you know, moderately. Limited means I don't know very much, or very limited, you know, you're here because it's the first you hear about it. Can we have a few more people answering? Come on. Yeah, we can do better. Yes. A few more, please. Okay. I can see that the answer is not really changing very much. So I think this is enough now. Thank you. Can we share, please, Maria? I think, guys, you have quite a hard job in your hands because as you can see, like 66% of people here have very limited. So this is the introductory webinar, and limited, they know a little bit, is 34%. So this is what you're dealing with today. And a final question for now. And this is one where you have to actually put a text in, right? So it's really simple as well. What is your organization currently using AI on? Can you put, at least if you're not using it at all, just put nothing. You know, if you're using it on something specifically, can you just put a word? I know that this is a little bit harder, but it will actually help the team then organize, you know, the kind of work that they're going to be doing going further in order to help you. This is really for the Joint Research Center at the EU Commission to be able to actually know, you know, what is it that you guys are doing so that they know what they can help you with. I've only had 8 people vote, so can we have a few more, please? I'd like to get to 20 if possible, at least. So it's not very much considering the people that are here, but I mean, it's always good to get, you know, at least a few people. Can I get a few people more, please? We're going to show you, so it's not like you're not going to see, you know, what other people have said as well. So can you just have a few more? Yes, 5 more. Go on, go on. A few more. Go on. But okay, 5, 4, 3. One more. 2, 1. Okay, let's show. We haven't quite got to 20, but 19 is also good. Okay. What is the results? I can't see the results. Okay, so I think we've had an issue because I cannot see the results. So Maria, can you go figure out what has happened, and then we'll share the results through the chat. And with this, we are already ready to start with the presentation. Please send your questions through the Q&A box at the bottom, so that we can actually use those at the very end. And without further ado, I'd like to ask Nikoleta to please share her screen, take her microphone off mute, and let's begin with the presentation itself.
Yes, give me a sec.
Absolutely. So, and welcome, by the way. I see there are people from Italy. We have a lot of people from Italy. This is good. Spain. Well, I saw someone from Kazakhstan, so in Estonia. Welcome. France. This is amazing. Please let us know where you're joining from. Perfect. You're ready to go. Yes.
Okay, so welcome also from me. As I said, I will give you a short presentation about our activities. First of all, we are the Joint Research Center. It provides independent evidence-based knowledge and science, so it supports EU policies in a nutshell by scientific research. We are based in Ispra, but we have colleagues in Petten. Okay, we have colleagues in Petten, and the JRC has also premises in Seville, in Brussels, in Kiel, and in Karlsruhe. We are the Energy Security Distribution and Markets Unit. We have three main domains of activity: gas, electricity, and security, distribution and digitalization, where we belong, and the markets. I will briefly present to you the activities for gas and electricity security. So we have a lot of work going to support DGNR to develop, for example, impact assessment on a new energy security framework. We are working on modeling the gas system, and we have also works on risk preparedness and exercises for resilience of the electricity system. A few words about the work for markets. We have a lot of activities to this respect. And for example, we have price simulations for gas price. We have activities on renewable energy sources investments, about the energy prices at nodal level, just to give you some idea. And I come to our activities. As I said, we are working for the digitalization of the grid. The project is called SHINE, Smart Homes, Intelligent Networks and Energy Community Ownership. We have various activities under this umbrella project. For example, we have energy justice and consumer empowerment activities. We have 2 laboratories based in Ispra and in Petten. We have also work directly collaborating with DGNR, for example, for the storage inventory, and also to develop the code of conduct for the interoperability of energy smart appliances. A few words about each of these categories. So for consumer empowerment, energy justice, we have various works, for example, citizen empowerment and participatory approaches on the energy transition. We have worked on regulatory sandboxes in the context of Net Zero Industry Act, and also a work to see the energy justice for AI. And we have analyzed the energy system digitalization through an energy justice lens. As I said, we have 2 laboratories, one in Petten with 2 main projects for hydrogen emergency response operation and sea salt advanced technology optimization. We have a big project for the code of conduct for the interoperability of energy smart appliances. Here we set the prerequisites for energy smart appliances for them to be interoperable in the market. We collaborate closely with the industry and with manufacturers. The version 1 is already out there, and it involves the prerequisites for white goods, HVAC. And now we're working on the version 2, which will include more categories of energy smart appliances like electric vehicles, PV inverters and batteries, and of course their interaction with the EMS, which is the energy management system. We have the European Energy Storage Inventory, and mainly it maps the European storage throughout Europe. We have a dynamic a dashboard and a map showing where this storage is located. We have important upcoming activities. For example, we are already participating in the AI Grids project, which is a project to create a pan-European energy foundation model. And we're also discussing with DGNR about our role in ambitious project. For example, they are discussing the Common European Energy Data Space, which includes the Energy Data Lab and the Energy Data Hub. The first one is a secure platform enabling pooling and controlled reuse of energy datasets. And the Data Hub will be fostering interoperability of data. This initiative is under the strategic roadmap for AI in the energy field. So it's this is ongoing. We are participating, and the AI grids is ongoing, and the other one is is being discussed for the future and our role in it. I have also an interesting slide here, our link to policies. For example, we have sustainable prosperity and competitiveness. This is a priority of the European Commission, and it includes different initiatives and further policies. I have just listed here some of them, like the Clean Industrial Deal, the Air Grids Package, the Electrification Action Plan, to which we are, our work is related to these policies. Another priority is social fairness and inclusion with the Citizen Energy Package, in which we are actively supporting it, the main pillars of the Citizen Energy Package. And then, of course, we have digital and technological leadership, another priority of the Commission. And I list here some of them, of the main policies that are under it. For example, the AI Act, for which we will talk further, my colleagues will talk further about it. I already mentioned the strategic roadmap for digitalization and AI in the energy field, in which we are participating and contributing. And then we have the Apply AI strategy, the AI Continent Action Plan, the Digitalization of Energy Action Plan. So all of these are European policies that are ongoing now. Some of them are already out there. Some of them are to be adopted soon. And I just wanted to show you here a little bit the bigger picture and where we stand to support DGNR, mainly DGNR for these policies. Okay. As conclusions, we hold many activities. AI, as you know, is a very hot topic, which we are very active. And we have twofold activities, scientific and policy support. And as I said, our work is linked to several initiatives and policies, regulations. So this is it from me. I'll pass on the floor to my colleagues.
So we're ready for you guys.
Okay.
Who's sharing?
I will share now.
Oh, perfect.
I'm trying. So.
It's challenging. Technology today is being a bit of a... Here we go.
Can you see the screen?
Yes. Can you put that in a large screen, please?
In the presentation mode?
Yes,
Okay.
that's what we need. Yeah.
Okay. Can you see it? Can you hear me?
Perfect. Yes, and we can hear you perfect as well.
Okay, good. Thanks a lot. So, good morning, everyone. My name is Davide Currò. I'm from the JRC Smart Grid Interoperability Laboratory, as I said before. Today, I'm very pleased to present our latest, one of our latest report on AI, which is how AI is shaping EU electricity grids, and focusing on the impact of the AI Act. we are not just looking at the software side, but at how the new European rules will change the physical way we are distributing. We are going to distribute the energy across the continent, because this is a crucial moment for our infrastructure. So this is the roadmap of my talk today. I will start with why we behind this study and the methodology followed. Then we will dive into some survey results, focusing on awareness of the regulatory readiness, use of AI in the energy sector, barriers and challenges, also having a look on the human oversight and the environmental impact, and also cybersecurity and social implication. So why this study? Strategic pillars. AI is representing a primary enabler for the green transition. And I really like this image because because it represents very well the shift we are experiencing in these days. So on one side, you can see the traditional goals, but in the middle you have this AI puzzle, let's say, that is the acts that provide the bridge to the other side. On the other side, I mean, to reach the net zero 2050 emission level, we need to manage a decentralized system. Which means that instead of having just a few big power plants that provide energy only one way, we will have at some point millions of, for example, solar panels, batteries, electrical vehicles, for example, heat pumps, etc. And the AI is the only tool that is capable, that can be capable of managing this proactive orchestration, so to speak. So, for example, it can balance the grid automatically when the sun goes down and millions of people plug their electric cars in at the same time in their home. And this is also the legal framework that was introduced by Nikoleta first. The legal foundation is the European AI Act, which is the regulation 2024/1689. And specifically, I want to mention the Annex 3 of this regulation that classifies AI in critical infrastructure as high risk. And I mean that because electricity is something vital for hospital, homes, etc., any AI error can have consequences. And in practice, the distribution system operators must follow stricter rules for documentation and safety that a company using AI is not using for simple marketing, for example. So it's something different. And we also align with the digitalization of energy action plan to ensure a resilient system. And so this is the survey scope and methodology. Our survey, so we sent our survey to several European DSOs. We use both multiple choice question and open-ended question. The respondents were 10 across 8 EU countries. And we wanted to hear the real story from them, from their application. We asked them, for example, what specifically makes them unready for the new regulation, to understand the human side of the digital transition, and also if barriers, of course, if they are facing barriers and challenges every day. And So one of the first result is represented in this slide, awareness and regulatory from the awareness and the regulatory readiness perspective. So first of all, 90% of DSOs, so distribution system operators, are aware of the European Artificial Intelligence Act and its upcoming requirements. Knowing a law exists is not the same, however, as being ready to follow it, which is kind of a problem, seems kind of a problem. And this in practice would mean that companies need to change their internal policies somehow and hire new experts, for example, to ensure every algorithm is compliant with the European AI Act and the requirements. And most of them are still in the early integration phase, trying to understand how to move forward. So, where AI is used today by the distribution system operators. First of all, mostly in demand forecasting and predictive maintenance. So the 60% of them are using AI in these fields. Using algorithm to predict when a cable or transformer might break, for example, is something that is already in place in the field, and also 50% use this AI in predictive maintenance, for example, and also 30% of the respondents use AI for theft detection. So, coming to the barriers and challenges that I briefly mentioned before, the biggest barriers are regulatory uncertainty and the skills, what is called the skills gap. I mean that it is very hard to find engineers who understand both high voltage electricity field and advanced data science. In practice, this would mean that innovation might slow down because the companies are afraid of legal risk, for example, or simply don't have enough trained people to implement technology. And also the high cost of explainability is also a measure hardly identified in the report. Data quality and availability. I want to mention the Article 10 of the AI Act, which requires high quality data set. But the thing is that many DSO struggles with data silos, which what I mean with this, I mean that information is stacked in different departments and cannot be shared sometimes. So like, for example, the maintenance team might have data that the planning team needs for some other reason, but because the systems are old, they don't talk to each other and the AI cannot learn effectively. So we need, as Nikoleta also said before, a common European data space to solve this problem. And coming to the human oversight, the human in the loop, it is very important. It is a very important thing in the field. We use the human in the loop approach, and I mean that the AI does the heavy calculation, okay, but a human must always have the what is called kill switch. In practice, this would mean that if AI suggests a dangerous change in grid voltage during a storm, for example, a human operator must be able to see it, understand it, and stop the process to ensure safety and accountability, of course. So the ultimate decision always belongs to a qualified expert, human expert. Another important issue is that regarding the environmental impact and what is called the dual role of AI, in my point of view. And because as a dual role, because the 60%, for example, of DSOs respondent see the AI as a green tool, which means AI can help reducing CO2 by making the grid more efficient. Okay. However, we must also see or monitor the energy consumption of the AI itself. So with this, I mean that we need to be careful. So if an AI software agent saves, for example, 10 units of 10 kilowatt hours of energy, but for running the system use 12, for example, units, it is not actually green, no? And right now it is not the consumption. This consumption is rarely monitored, and this is an area that we need more transparency and more effort. Regarding the cybersecurity and the technical robustness, security is something that is not negligible, of course, and high risk AI must be resilient against attacks in general. So in practice, this would mean that hackers trying to trick the AI into thinking the grid is stable when it is actually failing is something that we want to avoid, of course. The DSO must have a fail-safe plan, let's say, a fail-safe plan, and if AI system is hacked or fails, the grid must automatically switch to a safe manual mode to keep the lights on, of course, and protect the physical infrastructure from damages. Beyond compliances, so most of the DSOs do not have formal codes of conduct, but they use daily cross-checking, which means that they compare AI results with traditional models every single day. So in practice, what does this mean? It means that if AI predicts a certain load, but the old methods shows something different or something very different from what AI is providing, the technician is able to stop the AI to check and check the errors. A key part from this process is the constant consultation what the data protection officers, the DPOs, and these DPOs ensure that while we test AI in field, we are always respecting privacy and security standard before moving to a full-scale rollout. Yeah, and social implication. This is another key aspect in the survey and in the report. We stress this in the report also. So the human factor is the main challenge. We need also the capacity building, and what does this mean? It means that we need to provide intensive training to the current workforce, and in practice, it means that the technician who has worked on the grid for, I don't know, 20 years needs to be taught how to interact with the AI system or assistant. So they can somehow work together as a team. Of course, one is in person and the other is not. And also active partnership between industry and academia are essential to maintain trust and stay competitive. And in conclusion, okay, yes. So let's summarize the key points. The AI Act is now our official foundation. For a safe and ethical energy future, we have seen that while 90% of DSOs are aware of AI potential, we still need to bridge the gap on the regulatory point of view. And in practice, this will mean focusing on 4 main areas. The first one is we must ensure that high data quality. We must ensure high data quality by breaking down internal silos. Second, we must maintain the human oversight and the monitoring. The third, we need to address the environmental impact, of course, of the AI models to make sure they are actually truly sustainable. And finally, we must invest in cybersecurity to protect our critical infrastructure from the digital threats. So if we embrace AI, not just a tool, but as a catalyst for intelligent growth and collaboration, we will lead, of course, to success and sustainable energy transition. That's all from my side. I pass the floor to Antonio.
Thank you, Davide. Let me share my presentation. Can you all see it? So stop me if it's not the case. So in this part of the
we
webinar,
can't see it, Antonio. Sorry.
That's good. Thank you for that. Yeah, in this last part of the webinar, I'd like to give you a more technical focused perspective on the applications of AI for the energy system. In particular, present you the scientific activities that we carry out at the JRC to support the deployment of AI solution in the energy system, show you some prototypes that we have developed, and also give you some ideas on the future perspective. What the future trends are going to be in terms of AI solutions for the electricity grid. Let me start with a few general considerations why we are talking about AI for energy at this moment. And because it's mainly because of 2 trends that are somehow colliding or happening at the same time. On one end, we all know about the very quick trends in terms of decarbonization and digitalization of our system, which in turn is leading to increased levels of uncertainty, variability, complexity of the electricity grids. So all elements that need to be tackled in order to ensure efficiency and resilience, robustness of our electricity sector. And this is a challenge, but at the same time, the ongoing digitalization of the system is also giving us part of the answers. We have improved sensing and metering capabilities that produce large amounts of data. We know much more in detail what is happening at different levels of our energy system. And here AI looks like some form of very suitable solution. We can make use of the large amounts of data that we have available to train AI tools. And these AI tools can allow us to make our system smarter, more efficient, and more robust. So this is, I'm going to give you some examples of the JRC activities in this area, how we're trying to promote and accelerate the deployment of AI solutions for the grid. And I'm going to start with some of the most straightforward applications. One that is very direct is energy forecast, which is very suitable and very straightforward to implement with AI techniques. In particular, I'm going to demonstrate how AI-powered tool can support different aspects of the energy system, and in particular of energy communities. For those in the audience who are not aware of these entities, renewable energy communities have been introduced in the clean energy package of the European Commission, and they're basically new legal entities that bring together different prosumers, consumers with their own renewable generation assets. And the idea is to promote citizen involvement in energy production and management. So enable collective and citizen-driven energy action and provide environmental, social, and health benefits to local communities. So the rationale behind these kind of entities is that we want to deploy the energy transition at a local level. We want local community to directly see and reap the benefits of the decarbonization of the grid. And it is in this context that we start, by now, a very long-term collaboration with the energy community of Magliano Alpi, which is the first Italian energy community, which originally was quite small, was willing to expand, but the community realized that they lacked expertise and proper tools to understand the behavior of the community, forecast the results of their expansion or planning operational decision, and they wanted some help. So we started this collaboration that involved also universities, in particular the Energy Center of the Politecnico di Torino, and ITC and the IT software company Fabbrica Digitale, which supported us in the development of the IT and AI related tasks. And the idea where the problem which we decided to tackle with AI was to analyze the behavior of energy communities. In particular, one of the main objectives of this community is to somehow align their demand and local renewable generation, because this allows this lead to cost saving for the members of the community, reduce emission, improve the efficiency of power system. But it is not an easy task. There are many elements to consider: the behavior of the consumer, how flexible their demand is, our number of types of consumers and prosumers, and also, for example, the location or the geographical extension. So it is important to develop scientific, technical tools that can take these parameters into account in order to support the design and planning of energy communities, and possibly also help with the preparation of plans for these communities. And that's where our AI-powered forecast tool for energy communities, which is called REC tool, comes in. So this is a tool that is meant to support design and management of communities. In particular, it can forecast the energy performance in terms of load generation profile and self-consumed energy. The tool is available online. It is completely open source. And it has a web-based implementation. This is an important point that I want to emphasize, because our activities in this area are not only focused on the development of scientific technical products, but it also tries to bridge a gap that exists, and we also saw it in the poll at the beginning of the session. There is a technical gap between the complexity that AI tools can have and their extended use by different energy stakeholders. For example, not necessarily engineers, but also small, medium enterprises, public entities, or private citizens that might not have the technical expertise that could be required to write. We try to reduce this gap by developing the tool, but then also trying to make it accessible to the general public. And I'll talk about this in more. So first, how does the tool work? This is what happens under the hood. I'm not going to go into the technical details. There are a few mathematical models, some more traditional ones like statistical sampling, Monte Carlo techniques, but here is where the AI comes in. We also have deep neural network. In particular, we have long short-term memory network, which are particularly suitable for the task at hand, which is the prediction of time series. And then the second key ingredient is data, which can be provided by the users, but we also rely on external database for PV generation, for weather, for historical demand profiles. And the tool can be used, as I was saying earlier, through a graphical interface, through the web, through a simple browser. And the user is asked to specify the type of model that we want to use for the analysis, the season that we want to consider, and then it has the possibility of indicating type, location, and size of each consumer and prosumer that operates in the community, specifying all sorts of details, such as, for example, the contracted power, if it has renewable generation installed, and so on. And this is the kind of results that the tool is able to produce. So it can forecast daily profiles of demand, generation, self-consumption, and it's also capable of running sensitivity studies. So it has the capability of indicating whether, in order to maximize self-consumption energy performance, the community should include more commercial, industrial users, should bring in more prosumers, more generation, more demand, and so on and so on. If you're interested in the detail, I've included here the QR code for the tool and for the code that has been written to implement our AI-powered solution, which is open source, is available on the open source platform of the European Commission. And if you're interested in the technical details, here are the scientific papers where we present our work. And I should mention in this regard that by starting working on AI applications for the energy system, we learned a lot in the sense that we also came to face some technical challenges that are always there when someone starts approaching AI-related activities. And one of the big challenges was data quality and availability. In terms of load forecast, it's always very important to have historical data that can be used to train the model, to tell the model what kind of trends and are to be expected going forward in the future. And this data, especially historical data for load profiles, are not always available. So what the next step in our collaboration with the renewable energy community and Fabrica with Digitale was, can we try to get rid of parts of the data which are the most difficult to retrieve and still make an accurate forecast? In particular, we try to understand whether we could make a prediction without having historical load data at the prediction stage. So what if, for example, we operate with newly connected households, data scarce environments where historical load profiles are not available? Well, the idea was, let's try to replace this information with alternative data. For example, the type of building we are considering, kind of weather conditions, and more importantly, about socioeconomic properties of the household that we are analyzing, which could be, for example, number of people, how many are working, how many people are staying outside of the house during the day, during the night, income level, instruction level. And on top of that, which is one of the most important elements, is synthetic features. So we might not have access to historical load profiles, but can we say something about the behavior of the user, about the type of appliances they have at their house, and use this information instead? Well, this is the kind of approach we follow. Short answer, yes, we can use alternative information to do our prediction and still maintain accurate forecast results. This was obtained by applying machine learning models like the extra-trace regressor that you see here in the diagram. And again, if you're interested in the results, in the technical details, I've included here our latest scientific paper. So I don't want to give you the impression that load forecast is the only field where AI can be straightforward to apply. The possible applications are many and are also quite heterogeneous. So I'm just going to give you a second example of the kind of activities we have conducted, which in this specific case pertains to the grid integration of EV charging stations. And this study, this experimental study, was conducting at the smart EV charging facility that we have here on the Ispra side of the JRC. It's quite small. We have 9 single-phase AC chargers, equipped also with a 60 kilowatt solar canopy. And the study was conducted with a sort of living lab approach, where the JRC site itself becomes a scientific laboratory. In particular, we made a deal with the JRC staff. They could charge their personal EV for free whenever generation energy from PVs was available. But in exchange, they let us run some tests on their EV for purely scientific purposes. So what was the main objective here? Here, the idea was to assess whether this simple EV charging infrastructure, which is quite common throughout the whole European electricity grid, could be used to provide ancillary services and regulation services to the electricity system by leveraging the flexibility of the EV charging process. So somehow by using, by considering the charged EVs as some sort of batteries that are connected to the system that need to be charged, but there is some flexibility in how the charging process is conducted. So we first ran some preliminary studies on how to improve the power tracking capabilities of the EV charging station, because that's not trivial, and the battery management system of each different EV behaves differently when a certain charging set point is provided. So we introduced additional control loops meant to reduce the tracking error within the EV charging facility. And then where artificial intelligence comes in is in the identification of EVs. Because if we want to use our EV charging station as sources of flexibility, as provider of ancillary services, then it is important to understand the flexibility resources that they have at each time instant. So how many EVs are connected, what type and model of EVs are connected, and also how much energy and what are the charging requirements in each case. At the moment, most of the AC charging facilities have limited monitoring and sensoring capabilities. And we try to understand if we could detect the type and model of EVs, not through cameras or through complex login, but simply by checking how they respond to a certain charging signal. So what we did was, each time a member of JRC staff plugged in a vehicle, we broadcast a short excitation signal meant to create a response in the EV. And basically, thanks to the logging system of the JRC, we're able to associate each type of response to a specific type of electric vehicles. We trained our artificial intelligence model with this data, and we were able to predict with a very high accuracy, over 90%, the type of model or the type of car that was being connected. And this means that any EV charging station with no monitoring capabilities can implement our algorithm and estimate in real time the EV fleet that is being connected. With further elaboration, we can also estimate the aggregate storage energy of the charging EV fleet. I think time is almost running out. So just to mention that at the moment, deployment of AI solution is spreading in all different scientific tasks we're conducting. We have recently used machine learning methods also in our more experimental studies, where, for example, we try to provide new models for efficiency of bulk energy storage systems. And just let me conclude with a few considerations about the next step. So I've presented a few specific application of AI approaches, but the idea is that moving forward, things will we expect things to change considerably. And I included here two of the possible evolutions of AI in the energy system. One is the so-called digital twin. I don't know if you're familiar with this concept, but this is in principle not directly related to AI. It is simply a virtual replica of a real systems, like, for example, the electricity grid. And this digital twin is meant to replicate the behavior of the grid, but it has the key feature that it receives live feed data from the grid in order to self-learn and self-improve. So it can monitor what is changing in the real world and replicate it at a virtual level. This task of self-adaptation and self-learning is particularly suitable for AI models. And here is where we expect AI to see greater diffusion moving forward. And the second element that I want to emphasize in terms of AI application is AI foundation models. So rather than using AI on cases by cases, the idea is to add an additional layer, which is this foundation model between all data sources that you see here and the fine-tuned models that you see at the top. And in this case, the foundation model can be used to then can be fine-tuned to replicate the specific models. That's it on my side. Happy to take questions. Thank you very much.
Thank you very much, Antonio, and of course, Davide, also Nicoleta. I just wanted really quickly to ask a couple of questions. We don't have a lot of time left, but I think if you don't mind just answering these couple of questions that I've put together, I really appreciate it. One is, you mentioned human oversight as one of the things that we have to make sure when we are developing AI. I just wanted to kind of, if you can go a little bit more into that, like what does that mean, that every decision in the end has to be overseen? What can be automated? Do you have any advice essentially for how people can make sure that they are following, properly, like, or like doing it right, if you like, because we know that AI has a lot of capabilities, but we also know that guardrails is one of the most important items in the list. So could you guys go into a little bit more detail about this, like human in the loop or human oversight need?
I can try to briefly respond to you. So with a human in the loop, I mean that the AI is never truly alone. So in a high-risk environment like power grid, the system is designed so that a human can intervene at any moment. So in practice, this means that AI propose and the human dispose. So for critical operation like changing the voltage or isolating a part of the grid, for example, the AI suggests the most efficient action based on the different data points, let's say, but a human is necessary a human to click to confirm, let's say, the choice, no? And another important point is like an active monitoring. So the operator doesn't just wait until the alarm is ringing, for example, but maybe they can use I don't know, dashboard to see how the AI is thinking. This is something that this is what I meant with human oversight, human in the loop in my in the speech and the presentation. Hope this is clear.
Yeah, it's just like in the end, if you require for every step a human, you know, it might in the end take just as long. I don't know. It's like balancing that, you know, what decisions need to be taken by a human versus a machine. But I understand where you're coming from. That in the end, the dispose and propose, I think, is really important. I think.
Yeah, that's the point. Yes.
And actually, Antonio is answering the question that we have on the Q&A box. So just one more question, if you don't mind. It's about, you guys have presented now like a few of the sort of AI projects that you were working on, and the ones that you're going to work on now, you know, digital twins and the AI fundamentals. Is there any way that, what else are you working on? And is there any way that like people could have sort of an opinion or propose things that would be like useful to them?
Yeah, maybe I can take that question. The example that I made, the reference that I made to digital twins and foundation model will keep us busy for the foreseeable future because of their holistic nature, because they encompass somehow the whole issue, the whole problem, and all the different elements of the system. So that's where the bulk of our scientific work will be. However, some parallel applications like the ones I've mentioned on renewable energy communities, on electric vehicles, are proceeding in parallels. We organize public dissemination events and seminars, including this one, where we can have feedback from the public. They can raise their issues, their concerns, specific areas of application where they would be interested to see more work. Feel free to contact us on our emails. We are open to suggestions on some areas that we might have missed, but there are worth of further investigation right now.
Thank you very much, Antonio. So just to remind everyone that actually you've got the email addresses for everyone in this webinar, so please reach out, you know, if you have any ideas. And also a link has just been shared with you. Nikoleta has shared it, where you can see the website and check the activities that they're doing right now. So without further ado, since we've already taken the allotted time, thank you very much, Nikoleta. Thank you very much, Davide. Thank you very much, Antonio. And thank you very much for everyone that has been there today with us. We look forward to seeing you in the next webinar. But for now, see you later.